Hello, Matthews, Gatos here. Welcome to Chapter 5, Lesson 9. In this lesson, we're going to be looking at log scales and applications. There's 3 applications we'll focus on. Richter scale for magnitude of earthquakes, sound intensity with decibels, and pH levels. So let's start with Richter scale. So a Richter scale is based on a log scale. So remember the common log has a base of 10. Same thing here. So a log has a base of 10. That's why the log scale has a difference of 10 intensity for every time you go up. So every time I have a difference in 1 unit of magnitude, it corresponds to a factor of 10 difference in intensity. So here's an example. If I have something that has a magnitude of 9 on the Richter scale compared to a magnitude of 8, 9 is 1 unit higher, so that means it's 1 factor of 10 more intense, which just means it's 10 times more intense. Now compare that earthquake magnitude of 8 to an earthquake of magnitude 6, for example. 8 is 2 units higher in the magnitude, so it will be 2 factors of 10 more intense, or 10 squared is 100 times more intense, and so on. As I go up the scale, it is more intense. As I go down the scale, it is less intense. So let's try completing this. We want to compare earthquake magnitude 8 to 7. So 8 is bigger than 7. It's 1 unit higher. So since it's 1 unit higher, the intensity will be 1 factor of 10, or 10 times as intense. Magnitude of 7 compared to 3. So 7 is bigger. It is 4 units bigger. So since it's 4 units bigger, it will be 4 factors of 10 times more intense, or 10 to the exponent of 4, which is 10,000 times more intense. Let's compare a magnitude of 4 to 6. Now 4 is less than 6. It is 2 units less. So that means the magnitude will be 2 factors of 10 less intense, or 10 to the negative 2, which is 1/100th the amount of intensity. 4.8 to 6.8, same idea, we just have decimals now. So this is still 2 units below 6.8, so it's less intense. So since it's 2 units below, the factors of 10 will be 2 factors of 10 less intense, or again, 0.01. Okay, let's compare some real life examples here. So in 1960, this is the most intense earthquake on record, 9.5 on the Richter scale in Chile. We want to compare that to the 1976 earthquake in Italy. So Chile 9.5, Italy 6.5. That is 3 units higher. So since it's 3 units higher, it's 3 factors of 10 times more intense, or 10 cubed is 1,000 times more intense. Now let's compare that to the earthquake in Colombia. So Chile was 9.5, Colombia 5.5. Chile is 4 units higher on the Richter scale, so it will be 4 factors of 10 times more intense. 4 factors of 10, 10 exponent 4, 10,000 times more intense. Okay, let's compare Turkey to Japan. Turkey measured 6.9 on the Richter scale. Japan measured 8.9 on the Richter scale. So Turkey is 2 units less intense than, or sorry, lower on the magnitude than Japan was. So it'll be 2 factors of 10 less intense. 2 factors of 10, or 10 squared, 10 to the negative 2, is 0.01. Okay, so we're not going to do this. I'm going to show you a different way of doing it. We're not going to do it this way. We're going to use our idea. So what happens if the magnitudes aren't whole numbers? It's going to be the exact same thing. So for example, if I had an earthquake of magnitude 6 compared to a magnitude of 4, so 6 compared to 4, 6 is 2 units higher than 4, so the intensity is 2 factors of 10 more, or 100 times more intense. And it is more intense because 6 is greater than 4. Now let's look at another example here. What if I then said, same idea, instead of 6 and 7, I had 6 and 4, sorry, I had 6.4 and 4.7. Now, How many times more intense is a magnitude of 6.4 compared to 4.7? Now it is more intense because 6.4 is bigger than 4.7. So I'm going to follow the same idea. I'm going to subtract. So up here I did that exact same thing. 6 take away 4. 6 take away 4 is 2. Same thing here, but we're going to go 6.4 take away 4.7 to figure out how many times more intense it is. Putting that into my calculator, you can see that it's about 50 times more intense. So a magnitude of 6.4 is 50 times more intense than a magnitude of 4.7. So we don't have to go up just by factors of 1 in the magnitude, because you can have a magnitude in between the whole numbers, but the process to find the answer is still the same. Okay, let's try this one here. So this is all instead of that page that I crossed off. Let's say we have an earthquake with a magnitude of 2, and we're comparing that to a magnitude of 5. So 2 take away 5 is 3. So it's 3 factors smaller, 3 units smaller on the magnitude scale. So it's 10 factors 3 times less intense. So 10 to the negative 3. Again, it's less intense because 2 is less than 5. So let's use this idea to do this question here. How many times as intense as an earthquake measuring 5.2 compared to an earthquake measuring 8.1? So I know that it is less intense because 5.2 is smaller than 8.1. So how many times less intense? I would just do 10 to the 5.2 take away 8.1 to find out how many times less intense that is. And there you can see is my answer. Okay, so I can round that and say that the magnitude of 5.2 is 0.001 times less intense than a magnitude of 8.1. So again, just because it's a log scale, it's going to be powers of 10, and you just subtract the exponents. Okay, so back to 312 in your notes. How many times more intense was the 1960 earthquake in Chile measuring 9.5 than the 2005 earthquake in Chile measuring magnitude 7.8? So the 9.5 one is bigger, so my intensity is going to be more intense. To figure out how many times more intense, I just subtract the magnitudes. Do that, and it's about 50 times more intense. Okay, let's try another one. Let's say we have a major earthquake. It has a magnitude of 7.5. It is 375 times as intense as a minor earthquake. So is the magnitude of the minor earthquake greater or smaller than 7.5? Well, other than the fact that we used major and minor, let's look at the numbers. So if I measure 7.5 and I'm more intense, 370 times more intense than the other one, that means that the minor earthquake has to be less than 7.5. If it was bigger then it wouldn't be 375 times as intense. It would be like 0.4 times as intense. It'd be a number less than 1. So let's use our strategy to do this instead of the formula that they have on your sheet. Okay, so we're going to go 10 to the 7.5 minus the minor, which we don't know, is going to equal to 375. So normally that's what we're solving for, the 375. This time we're actually just solving for our variable. So whenever I have something like this, I'm going to just use bay. So I'm going to isolate my power, which it is, and use bay. So I'm going to do log of base of answer equals to the exponent. Okay, so log base 10 of 375, that's just a common log, and that's 2.57, etc. So I have 2.57 equals 7.5 minus x. So I want to isolate x. So what I'm going to do is I'm going to add x to both sides and subtract 2.57 from both sides. So then if I add x to both sides, I'm going to get x equals, over here, 7.5 take away 2.57, etc. Okay, and I have that on my calculator. I'm not rounding. So I just do 7.5 take away that, and The magnitude is 4.9. So as I expected, it is less than 7.5. Okay, let's look at sound level. So sound level is the decibel scale. So a loudness of sound was originally measured in bells, named after Graham Alexander Bell. But the current level that we use is decibels, which is 1/10 of a bell. So basically what we need to remember when we're dealing with these is that take all of the bells, to figure out how to move, bells are just decibels divided by 10. So I can take all of these numbers on the decibel scale and divide them by 10. That is super important. Once you've done that, the bell scale, not the decibel scale, the bell scale is a log scale. So a difference in one bell is a difference of 10, a factor of 10 times intensity. But it's really important that you are dealing with bells, not decibels. Okay, so a power saw, 120 decibels, is blank times as intense as a telephone dial tone at 80 decibels. Well, for all of these, notice these are all in decibels. I want them all to be in bells. So that's the very first thing that I'm going to do. Change all of these to be in bells by taking the decibels and dividing them by 10. Now, bells are a log scale, decibels are not. So 12 compared to 8. 12 is 4 units bigger. So the intensity is going to be 4 times bigger as well. 4 factors of 10. 10 to the exponent of 4. The jet engine at 14.5 compared to the threshold of pain, doesn't that sound lovely? At 12.5 bells. So this is 2 units higher, which means it will be 2 factors of 10 more times intense, which is 10 squared, or 100. A whisper of 3 bells compared to a conversation level at 6 bells. The whisper is less intense. It is 3 units less intense, so it will be 3 factors of 10 less intense, or 0.001, 1,000th. Okay, so we're not going to use these formulas, we're going to use our strategies. And this goes for the diploma, the unit test, the quiz, anything like that. You can use the measurement of understanding the log scale and how that works to do the questions. We don't need an equation. We can just use our common sense here. So how many times more intense is the sound of a piano, 67 decibels, compared to a whisper of 22 decibels? Remember, a decibel scale is not a log scale. The bell scale is a log scale. So that's the very first thing that we need to do, is put it into bells. Okay, so the piano is more intense than the whisper because the bells are higher. To figure out how much times more intense, I subtract my sound measurements. So 10 to the 6.7 take away 2.2. That will give me how many times as intense it is. So I'm going to round this to the nearest whole. I'm going to say it's about 31,623 times as intense. So the piano is that many more times intense than the whisper. Okay, we're not going to be doing that one. We're going to move on to pH scale. So this is math class, it's not a chemistry lesson, so if you are not familiar with pH, do not worry. All the information that you need will be given to you in the question. What you do need to know is that pH is also based on the log scale. Now, pH is just a number between 0 and 14, and right smack in the middle is a pH of 7, which is considered neutral. Okay? So the bigger the number, it's increasing in alkalinity, or if you guys are in chemistry, you probably refer to this as basic. And then the lower the number, the more acidic it is considered. Now, when we're talking about these are powers of 10 because that's the concentration of hydrogen, which is a power of 10. Okay, so similar to all the other scales, pH is logarithmic. So a difference in 1 unit of pH is a factor of 10 difference in intensity. So what you need to remember is that the acidic is the smaller number, alkaline is the bigger number. Just remember that they are in alphabetical order. So I have acidic, neutral, neutral is at 7, and then I have alkaline, or for my chemistry buffs out there, basic. Okay, just remember they're in alphabetical order: acidic and then alkaline. That's how I remember it, because it's been a long time since I've taken chemistry. So to figure out how much more acidic or alkaline it is, you just do 10 to the difference of the pH. So the exact same thing we were doing with Richter scale and sound. Okay, so let's look at this. Pure water, swimming pool water, and sea water have pH levels of 7, 7.5, and 8.4 respectively. So pure water, swimming water, and sea water, the acidity. Sea water, that's 8.4, is how many times as alkaline as pure water. So remember, the higher the number, the more alkaline, and since seawater has a higher pH, it is more alkaline. To figure out how many times more alkaline, I'll take the pH of seawater, subtract pure water. So I'm going to have 10 to the 1.4. And then I can just put that into my calculator to figure out what the intensity factor is. So I just do 10 to the 1.4, and I will get that it is about 25 times as alkaline as pure water. Okay, seawater is how many times as alkaline as swimming pool water. So remember, the bigger the number, the more alkaline. So seawater at 8.4 compared to swimming pool water. Seawater is higher, so that's why it's more alkaline. 8.4 take away swimming pool water, 7.5. So in doing that, I just subtract those numbers and I get 10 to the 0.9. So it's going to be just a little less than 10, because 10 to the 1 would be 10. So it's going to be about 7.9 times as alkaline, because they're pretty close together. Okay, you're going to have some questions involving pH. And I've seen on the diploma, they always like to have like at least one question based on pH. So here's the formula which will be given to you in the question. pH is equal to negative log of hydrogen. So breaking this apart, pH, a number between 0 and 14. Negative, that just means -1 times by the log. This is a common log, which means it has an invisible base of 10. And hydrogen, it's in moles per liter. It's always written in scientific notation. So the two types of questions that you can be asked is, given the hydrogen, what is the pH? Or given the pH, what is the hydrogen? So let's try an example of each. So a patient gave a urine sample which was found to have a pH level of 5.7. What is the hydrogen ion concentration? Okay, so what we want to do is we want to plug it in, and then we're going to use circle of logs. So, pH level of 5.7 equals negative log base 10 of hydrogen. So I want to isolate my log and then use circle of logs. So isolating my log, I divide both sides by -1. Log base 10 of hydrogen. So as soon as I do that, I just use my circle of logs to put it into exponential form. So I get that hydrogen is equal to 10 to the -5.7. Now, for those of you that are in chemistry, you're probably saying, Mosquitoes, I already knew that hydrogen was 10 to the negative pH. Can I just use that? And my answer is no, it's math class. No, of course you could use it. Okay, so if you guys know that little shortcut for hydrogen, 10 to the negative pH, you can totally use that. Okay, so I plug it into my calculator and I get this as my answer. Now that's an answer in scientific notation. It just doesn't look like it. It's this whole number here multiplied by 10 to the e stands for exponent, -6. That's what that number means. And we want to answer it in scientific notation. Okay? So there's that little chemistry shortcut that we just mentioned, 10 to the negative pH. You can use that shortcut. You still have to plug it into your calculator, and don't worry about significant digits. They want it to 1 decimal place. So I'll call that 2.0 times 10 to the -6. Okay? And that would be your hydrogen ion concentration. So again, you can totally use that chemistry shortcut. I'm fine with that. Let's look at a question going the other way around. So determine the pH to the nearest tenth if the hydrogen ion concentration is 3.4 times 10 to the negative 4. So pH is equal to negative log of the hydrogen. And this one here, I like these ones because they're just plug it straight into the calculator because this is just a number. So that's exactly what I do. Plug it into the calculator and I get 3.5 as my answer. So that's pretty basic. Okay. So to summarize, all of these scales were a log scale. So all that means is a magnitude difference, a Bell difference, or a pH difference of 1 correlates to an intensity difference of 10. That's all it means. Okay? So with pH, 7 right in the middle is neutral, 0 to 6 is acidic, 8 to 14 is more alkaline. Remember, it's in alphabetical order, acidic and then alkaline. And then remember to isolate your log before switching to exponential form. And again, feel free to use the 10 to the negative pH as a little shortcut. Totally fine on that. 6.5 on the Richter scale. Time to switch you to decaf. Okay, you guys can go and do your assignments. I have detailed solutions on D2L. I hope this lesson helped, and I'll see you for the next one, which is the practice test.